Good morning everyone. So for today's class, we're just going to continue with the chapter Solution, Suspension and Solubility. Okay, now we go to the last subtopic, Solubility. Okay, as you know that salt dissolves easily in water. Okay, but however there is a limit to how much salt can dissolve in water. Okay, this limit depends on the solubility of the solid. Okay, so the definition, okay, or the meaning of the solubility, okay, is the maximum amount of solute. Okay, you know why solute, right? Okay, a substance that dissolves in solvent. Okay, so that can dissolve in a 100 gram of solvent. Okay, solvent is a liquid, okay, at a given temperature. Okay, for example, like let's say you have, okay, the sodium chloride. Okay, so the solubility of sodium chloride in water at a temperature of 20 degrees Celsius is 38 gram per 100 gram of water. Okay, so that means that only 38 gram of sodium chloride can dissolve in 100 gram of water at 20 degrees Celsius. Okay, that's what it means by solubility. Okay, so now move on to the next slide. Okay, so factors affecting the solubility. Okay, number one is the nature of the solvent. Okay, followed by nature of solute. Okay, and the last one will be the temperature. Okay, all of these three are the factors that will affect the solubility. Let's see one by one. Okay, nature of the solvent. Okay, so explanation. Okay, let's say iodine dissolves better in alcohol than in water. Okay, so therefore iodine has higher solubility in alcohol than in water. Okay, something like that. Okay, so the solubility of a solid is different in different solvent. Okay, a solid may be soluble, okay, in a certain solvent but insoluble in another solvent. Okay, for example, like let's say you have a salt. Okay, salt dissolves readily in water but not in solvent. Okay, like alcohol or other solvent. Okay, so iodine is almost insoluble in water, okay, but dissolve very well in alcohol. Okay, so that's why this is the explanation, okay, about the nature of the solvent. Okay, now we move on to the next factor, nature of solid, number 2. Okay, so different solids have different solubility, okay, in the same solvent. For example, like salt dissolve in water better than baking soda does. Okay, something like that. Okay, the last one with the temperature. Okay, so more substance can dissolve in the same amount of solvent at a higher temperature. Okay, for example, like coffee dissolve. Okay, sorry about this one. Okay, this the bottom one. Okay, you cannot see. Okay, but it say coffee dissolve better in hot water than ice cold water. So as you can see that, okay, hot, which means high temperature, so more substance can dissolve, okay, can dissolve easily at a higher temperature. Okay, that is the factor which affecting the solubility. Okay, rate of dissolving. Okay, let us think. Okay, to make a cup of tea, okay, a tea bag is placed in a cup of water. Okay, tea bag. So sugar is then added. So how can sugar be made to dissolve faster? Right. So let's see in the next slide. Okay, so rate of dissolving. So as you know, the factor that's affecting the solubility, okay, or the dissolving, okay, you must put hot water, okay, which means the temperature is high, okay, or you heat up the tea. Okay, after that you have to stir the tea like the diagram here. You hold a spoon, then you stir you tear the liquid here inside the glass or a cup. Okay, and then you use a sugar crystal instead of large lumps of sugar. This talking about the size. Okay, crystal, okay, the size is smaller compared to the lumps, okay, large lumps. So the rate of dissolving is the speed, okay, at which the solid dissolve in a fixed amount of water. Okay, let's see this factor. Okay, so what are the factors that affect the how fast a solid dissolves? Okay, so temperature, so how the rate of dissolving is affected. Okay, so the higher the temperature, the faster the solid dissolve. Okay, for example, like rate of dissolving increases with higher temperature. Okay, rate of stirring, the faster the mixture is stirred. Okay, the faster you move your hand fast. Okay, you move your hand, the faster the solid will be dissolved, okay, into the solvent. Okay, size of particles. Okay, the smaller the solid particles, okay, which is the sugar example, okay, the faster the solid dissolve. Okay, for example, like 10 gram of powder sugar dissolve faster than 10 gram of rock sugar. Powder, the size is smaller compared to the rock. Okay, rock is a bigger size. Okay, powder is like a flour. Okay, so this size is much more smaller and higher surface area, okay, compared to the rock sugar. Okay, if you want to understand more about the particle size, let's say you have a cube of dimension of 2 cm by 2 cm by 2 cm. Okay, this one, 2, 2 and 2. Okay, 2, 2 and 2, 2 and 2. Okay, so the total surface area will be 2 times 2 times 6. 6 by 6 because we have 6 faces. Okay, this is cuboid, cube. Okay, so you have 6 faces, so that's why you have to times 6. 1, 2, 3, 4, 5, 6. Okay, at the bottom one. So the total surface area is 24. Okay, let's say you cut half of this box like this. Okay, cut half and then half from the top and the bottom and the middle, something like that. Okay, let's say 2 times 2 times 2 cube was cut into 1 times 1 times 1 cubes. Okay, something like that become this one smaller one. Okay, then you have a 8 cube. 8 which means 1, 2, 3, 4, 5, 6, 7, 8. Okay, at the back there. So you have, that's why times 8. Okay, this 8 is coming from the cubes. Okay, upper you have 1, 2, 3, 4, front, 2 at the back, 2 at the front, okay, 2 at the bottom, front, and 2 at the bottom, back. Okay, so that you have 8 cubes. Okay, so if you times this one, 1 times 6, because why 6? Because you have 6 faces. Then again you times 8, so your because you have 8 cubes, right? 1, 2, 3, 4, 5, 6, 7, 8. So that's why the total is 48 cm square. Okay, the surface area. Why become 1? Because you only cut the big box. Okay, this one into half. So what can you conclude from this? Okay, so when the particles are smaller for the same mass of substance, there is higher total surface area coming into contact with the solvent. Therefore, okay, at the end, smaller particles dissolve faster. Okay, just remember that the smaller the size of the particle, okay, the higher the total surface area coming into contact with the solvent. So at the end, the rate of dissolving, okay, is faster. Okay, just remember like that. Okay, smaller particle size, okay, the rate of dissolving is faster. Okay, so that's the end for this topic. Okay, thank you guys for listening and watching this video.